Today we are gonna work off with October-November 2017 का paper, ठीक है? The question goes on like the element sodium to sulfur react with chlorine. The melting points of some of the chlorides formed are shown. Predict the shapes of AlCl3 and PCl3. Right? Draw diagrams to show the shapes and state the bond angles. Before you move on, you need to realize, go to the periodic table and check. Aluminium is in group 3. Right? Aluminium can make 3 bonds with chlorine. And this is what it looks like. Okay. All 3 electrons are consumed. There are no lone pairs. There are only 3 bond pairs. With 3 bond pairs, we have an angle of 120 degrees and a shape of trigonal planar. PCl3 phosphorus is in group 5. Phosphorus, if asked to make bonds with 3 chlorine, would somewhat be like this. You need to understand that it is in group 5, right? However, it is using up 3 of its 5 electrons. So there is a lone pair involved here somewhere. We have 3 bond pairs, 1 lone pair, and the corresponding angle would be 107 degrees. For this, for PCl3, the shape is called trigonal pyramidal. For the other one is called the trigonal planar. Moving forward, they ask you, explain in terms of structure and bonding why the melting point of SiCl4 is much lower than NaCl. Now you need to understand that Si is a non-metal bonded with a non-metal, whereas NaCl is a metal bonded with a non-metal. Right? SiCl4 is a simple covalent molecule. With weak van der Waals forces of attraction. Whereas NaCl has an ionic bond with giant crystal lattice structure. Because NaCl is an ionic bond, it will therefore be a stronger bond than SiCl4. Moving forward, they ask you explain why the melting point of SiCl4 is higher than that of PCl3. Remember, SiCl4, you need to understand first, SiCl4 is a non-metal bonded to a non-metal as well. Whereas PCl3 is also non-metal bonded to a non-metal. You need to understand that SiCl4 will have a greater MR because of which it will have more electrons, and more electrons would mean more temporary induced dipole-dipole forces. Next part, they ask you draw the dot and cross diagram of a molecule of SiCl4. Show the outermost electrons only. You're gonna simply make Si. Next part, they say at 450 Kelvin, phosphorus 5 chloride decomposes to form phosphorus 3 chloride. Okay, the enthalpy change of the formation of PCl3 under these conditions is given below. For this reaction, the enthalpy change is this so and so. For the formation of PCl3, the reaction value is minus 320. आपसे कह रहे calculate the enthalpy change of formation of PCl5 under these conditions. Don't you think if I reverse my equation somewhat like this, that would cause PCl5 to be formed? Reversing my equation would mean the sign reverses. And you need to understand that enthalpy change of formation now is enthalpy change of formation of PCl3 and the enthalpy change of reaction of this reaction. Moving forward, they ask you state and explain the effect of increasing the temperature on the rate of decomposition of PCl5. Please understand that if I am increasing the temperature, the rate will always increase because the collision frequency of the particles will now increase. So the energy of these particles is greater than the energy of activation. Next part, they ask you state and explain the effect of increasing temperature on the percentage of PCl5 that decomposes. Decomposes meaning to say इस reaction की बात कर रहा है. It is an endothermic reaction. तो अगर मैं टेम्परेचर बढ़ाता हूं, ठीक है, तो आपका फॉरवर्ड रिएक्शन जो है वो फॉरवर्ड रिएक्शन जो आपका होता है यार वो एंडोथर्मिक है. तो आपसे पूछ रहा है परसेंटेज डीकॉम्पोजिशन बता दो, मतलब के परसेंटेज डीकॉम्पोजिशन मतलब कि रिएक्शन ट्रिगर हो रहा है, आगे की तरफ जा रहा है, मतलब कि PCl5 is decomposing more. So your answer should be that percentage decomposition of PCl5 will increase as forward reaction is endothermic. This will gain you credit. Percentage decomposition of PCl5 अगर बढ़ रहा है मतलब के अगर मेरे पास परसेंटेज डिकम्पोजिशन ऑफ PCl5 बढ़ रहा है मतलब कि मेरा फॉरवर्ड रिएक्शन बढ़ता जा रहा है, मतलब कि PCl5 आसानी से ब्रेक डाउन हो रहा है।